Last time we used confidence intervals around a point estimate to estimate a population mean. Today, we're going to create confidence intervals around another point estimate to estimate the difference of two population means, and we're going to assume that the samples were independent. Let's begin. Remember that a point estimate is another word for sample mean, right? We take a random sample of size n, and we figure out its place of that sample mean in the sampling distribution. Okay, here we're going to use a point estimate to estimate the difference between two population means. Okay, so here's an example. We have an online test and a paper test, right? Instructor gives the exact same test on paper and online to different sets of students. Now, it just so happens that both sets of students had 35, but they actually could have had different sample sizes if it worked out that way. Okay. Just to give you some basic info, we know this. I entered this data into Minitab and it gave this, so you don't have to do all that. Okay, that's what we know. So they want us to construct a 95% confidence interval for the difference in mean scores between the paper and online exams, right? So we're interested in, not just how did the people do on the paper test, how many did they do on the online test, but what's the difference between their mean scores. So what we did was we found the average score for the paper takers, the average test score for the online takers, and along with the standard deviation. And actually, sorry, this is a mistake. This should not be sigma. This should be S because it's a sample standard deviation. Sorry about that. Okay, so there you go. This is information again. I calculated this in Minitab, so you don't have to. So how do you do this? How do you create a confidence interval for the difference? We're going to do the long and drawn out way, and then I'll show you how to do it quickly in Minitab. Okay? So note that in this case, we're dealing with two populations, and we're interested in the difference. I said the difference between their means. Okay? So here what we're going to do is we're going to find both sample means, right, in order to do this. They're x1 and x2, by the way. And then we're going to find the point estimate. X bar 1 minus x bar 2. Sorry, actually, this should be x bar 1 and x bar 2. Okay. So remember that since x bar 1 equals, was that 68.4, I think? Yeah. And x2 bar equals, I think it was 71.3. We have that the point estimate. Let me put this down here. Oh. This guy equals negative 2.9. Now, of course, you could have reversed them to get positive 2.9. Okay? For the point estimate. Right? So the point estimate is negative 2.9. Okay? Next, we're going to do is find the degrees of freedom. By the way, note that we're assuming we do not know the population standard deviation. Right? That's a pretty safe assumption here. So that's going to be the lower between N1 minus 1 and N2 minus 1. Now, again, you can choose whichever one you want for N1 and N2, but just be consistent, right? We decided that population 1 was the paper people, and the population 2 is the online people. Also, it turns out, in this case, N1 and N2 equal the same thing. Okay? Then we're going to find the corresponding t-value, which remember is t sub alpha over 2. Okay? So again, in this case, nothing super complicated here. Degrees of freedom, in this case it equals N1 minus 1, which actually equals n2 minus 1, which equals 35 minus 1, which equals 34. Now, how do you find the corresponding t-value? Well, you can use the t-chart in the book, or you can do Minitab, you can do graph, probability distribution plot, view probability. Make sure that you're set at the t-distribution, not the normal distribution. Enter your degrees of freedom, which is 34. We want a specified probability since they wanted a 95% confidence interval. So make sure to choose middle, and then make sure to choose the probabilities outside of 95, right? 95% in the middle means 5% elsewhere. That means 2.5% on the left, 2.5% on the right. So that's what it makes us enter in. I don't love that it does that, but that's how it makes us do it. Anyway, you press OK, and then look what it gives us. See that? That's 2.032 right there. That's our t-value, okay? Okay, so there we go. Next, what we're going to do is we're going to find the standard error, which remember we call that SE. And in this case, it's going to be a little more annoying than before. Nothing crazy, but just a little more involved. Note that we've got sort of the sample variances, right? Right, but because we squared the sample standard deviation, or the standard errors that are squared, right? But then we take the square root of them. That turns out that's what the standard error for the difference is. Let me actually just make this a little better right here. It's right there. Okay. So then what we're going to get is the margin of error, which is t alpha over 2 times, I guess I should call it the standard error, times the standard error, which equals 2.032 times the square root of, now remember, this was data that I gave you, right? S1 is 10.2 over 30, squared over 35. Right? So we just multiply this out, all right? And this is our margin of error, right? And let's see what that gives us. And we're getting, looks like 5.077. I'll just round it to 5.08. Right? Okay, so that's what we get. 5.08. Okay, so that's our margin of error. Now remember, what's the confidence interval? Well, it's going to be our point estimate. And then we're going to subtract the margin of error. And then we have our point estimate. And we're going to add our margin of error. So let's see what we get here. We're going to have our 95% confidence interval is going to equal negative 2.9 minus 5.08. Actually, I guess if we're using 2.9, was that what it was? Was it negative 2.9? Yeah. Negative 2.9. Maybe I'll just round this to 5.1, actually. Just round it to 5.1. Okay. Negative 2.9 minus 5.1, negative 2.9 plus 5.1. And that's the same thing as, was that negative 8 to, whatever that is, 2.2. Okay. All right. So that's what we get. Okay. So that's our confidence interval. Now, again, we could have been a little more precise if we wanted, but, if we rounded to the hundredths, but that's what I got right there, okay? Now, the book says to interpret the result if necessary, right, which actually leads to our... So this is how we create the confidence interval, right? But now let's look at the second part of the question, right? Instructor claims the mean scores are the same for both the paper and the online versions. Does the confidence interval contradict the claim? Well, if the mean scores for paper and online were the same, then what would their difference be? It would be 0, right? Is the difference of 0 within the confidence interval? Yes, it is. So no, the confidence interval does not contradict the claim. Right, because the difference 0 is in the confidence interval. Okay, done. That's all we need to write. Now, let's take a slightly easier approach, right? Suppose we didn't want to do all that because that took a little bit of time. What we could have done, now that we know how it's done, now that we know what's involved, is we go to basic stats, and we're going to do 2 sample t, right? And we're going to summarize the data, right? So let's see. For sample 1, the sample size was 35. Same with sample 2. For the first one, the sample mean was 68.4. For the second one, it was 71.3. For the first one, the standard deviation was 10.2. The other one, it was 10.7. Again, this was given data. Options, we want it to be 95%. Leave the hypothesized difference stuff alone. Don't check that assume equal variances box. We're just going to do this. Okay. So you see here they get a slightly better estimate for their confidence interval. But same sort of thing, right? I got -8, they got -7.9, right? I got 2.2, they got 2.1, right? So we get this. And so then what we do is we're just going to paste this right here just to sort of show. Oh, no, never mind, sorry. We didn't have that right there. We have it right here. Just to show you, we have, it's right here. Now, the reason for this isn't just because I was a little imprecise. The standard error here is actually a little bit of a, sort of a nicer approximation. So that's why we have the slight discrepancy. Now, anyway, when we're doing this, when we're creating these confidence intervals, in order to do this, we need to assume a couple of things. Both samples are random. We always need to do that. Both samples are independent of each other. And both samples are either large, right, which means that N1 is greater than 30, and N2 is greater than 30, or from normal populations, right? Because if the sample size is small, then we need to know that it's from a normal population. Right, now remember that 2 samples are independent, because we haven't seen this much before, if they don't affect each other. Right? Here's another example, right? 2 different kinds of fertilizers, right? Fertilizer A has 16 different plots of land. Fertilizer B has 12. We're looking at the number of pounds of harvested fruit, right? Notice that the number of plots for fertilizer A is not the same as it is for fertilizer B, but that's okay because these are independent. Also note that, did they mention that it's normal? Oh, no, they don't mention that it's normal, but we do need to check that it's normal. Why do we need to know that the populations are approximately normal? Well, it's because the sample sizes are small. less than or equal to 30, right? Well, here are the box plots, okay? These populations are normal. Right, remember section 7.6, right? There's no skewness, there are no outliers, right? And we don't really know about modality, but no reason to think it's not unimodal. So, all right, construct a 98% confidence interval. Well, now that we've got, now that we know how to do it, let's go in here. I've already entered fertilizer A and B data in. Stat, basic stats, to sample T. And at this point, I think we can do each sample's in its own column. Sample 1 is fertilizer A. Sample B is fertilizer B. Let's just make sure, okay, we want to change this to 98%. Leave everything else alone. And ignore all the other stuff right there. That's the confidence interval. Right? It's nice that they give us some summary stats. Very nice. But really, we're just interested in the confidence interval, if that's all it asks for. Maybe I'll include that stuff too, just because it's kind of nice, right? Well, okay. Maybe I will just crop this a little bit. We have enough space just for the confidence interval, okay? There we go. Okay. So just want to point out the reason that, Minitab will give us a slightly more exact answer than what we got when we calculated by hand is because they were using a slightly more complicated formula for the degrees of freedom. Okay? That's what they get. So when we calculate things by hand, we use the simpler method of, I guess, just degrees of freedom equals the minimum of, I guess I'll write it like this, N1 minus 1 and N2 minus 1, right? Whichever of those is less, right? But, again, technically speaking, it's really this. But who wants to do that by hand, right? So that's what we've got for today.